Hey y'all, welcome back. So today we're working on some problems using the law of sines. Specifically, we're going to solve all these triangles by finding their missing angles and sides using what is known as the law of sines. So just to kind of refresh you, I'll go ahead and type it out here. We've got side A divided by the sine of angle A, and that ratio is going to be equal to every pair of a side and angle. So side B divided by sine of angle B, and finally side C divided by sine of angle C. So you can basically set any two of these ratios equal to each other depending on what the needs of your problem are. But this is the law of sines. Can I fit it up there? You know what? I might just, well, okay, I'm overthinking this. I'll just put it up there for now. Okay, so in each of these cases, we're going to use a law of sines to solve for the missing sides and angles. So let's look at number one. They've given us angle A, angle B, and side A. And we're going to use that to find side B, side C, and angle C. So we're going to set up a law of sines here. And you want to pick the combination that you know. So in other words, like I want a pair of A's or a pair of C's or a pair of B's to be one of my ratios. So in this case, I will definitely want to use A because I know both angle A and side A. And so we'll go for side B first. So we're going to set up our law of sines here. Side A is 20, angle A is 30 degrees. I guess we can throw in a little degree symbol there to be a little bit more accurate. B is what we're trying to search for, so that's just going to stay B. And then angle B is 45 degrees. All right, so from here, we can rearrange this for B. Now to do that, we need to multiply 20 by the sine of 45, and then we will divide by sine of 30 degrees. So we went over in class, we went into a little bit more detail on those steps. I'm not going to show every little step here. Just know that you use what is known as the cross products property to, what's casually known as cross multiplying to solve this. So what we end up is B equals 20 times the sine of 45 degrees. And all that we will divide by the sine of 30 degrees. Now this one we really don't need a calculator for, although most of them we will. And the only reason we don't really need a calculator on this one is because we know what sine of 45 and sine of 30 are. But I'm going to go ahead and use a calculator anyway, just because we're going to have to do that for the majority of these problems. Now I'm going to say approximately equals here because I am going to estimate. So let me go ahead and pull up a calculator, and we will. We'll compute this out. So we create a little fraction here. We've got 20 times the sine of 45 over the sine of 30. Now before I hit enter, I'm going to double check and make sure my calculator is set up correctly. You need to make sure that when you hit mode, you are in degrees here, not radians. So I've got the wrong setting here because all these angle measures, the 45 and the 30, are both given in degrees. So I need to make sure my calculator is in degrees. And it should be in degrees, I think, for all of these problems. I don't think there's a single one that gives you in radians. So I shouldn't have to worry about that after changing it the first time. Now I can quit, and I'll go ahead and hit enter, and there we go. So now we can see the length of side B is approximately 28.3. All right, I'll just go to the nearest tenth here. Okay, so that's kind of the general idea here. We're just going to do that again for angle C, or side C. The thing about side C is that we do not know angle C. So we got to figure out angle C first before we can figure out side C. So luckily, when you have two angle measures here, like we know we have got 30 and 45, to find the third one, we will use the fact that the sum of all of the interior angles of a triangle add up to 180. So if I want to find, say, angle C, I know that's going to be 180 minus 45 minus 30. So angle C is going to equal, let's double check that. I'm using a lot of calculator today. 180 minus 45 minus 30. Looks like we get 105. So C is going to equal 105 degrees. And all right, so we've got side B, angle C So the last thing we need is side C. We got this one and we got this one, right? So for side C, we're going to set up another law of sines, very similar to this. In fact, I'm just going to copy and paste this, except instead of B and angle B here, we're going to look for side C. And we just figured out what angle C was. It was 105 degrees. So we'll put that right there. I might have to make this a little smaller to make all this fit. Here's what we'll do. We'll change this all to 16-point font, and I'll just zoom in a little bit. I know you guys are like, come on, hurry up. You can just fast forward the next like 30 seconds here while I do this if you don't want to wait for me. I should learn how to speed up the video. All right. I think we'll have a little bit more success here. Okay, so anyway, now that we know that the angle measures 105, we can do this. And we're actually going to solve this out pretty much exactly the same way. We're going to cross multiply and divide. So we'll have 20 times the sine of 105 divided by the sine of 30. This is going to be something else that we're going to put in the calculator. Let's change this to C, which is what it is. Don't want to get too copy-paste happy here. All right, so anyway, let's go ahead and type this in. I'll just copy that so I don't have to retype everything. And so we get 20 times the sine of 105 degrees divided by sine of 30, and that gives me approximately 38.6. All right, so there we go. We got all three of these, and that is pretty much what we're going to do on all these problems. So as soon as you kind of master setting up the law of sines, you're going to work out all of these basically the same way. So I guess what I'm saying is we can sort of copy and paste all of this over to essentially every problem and just change the numbers as we need to. Okay, so don't look at any of this work yet, because we need to go in and actually see what we've got here. Oh, hey, I should probably zoom out a little bit so you can see that. Is that going to work? Yeah, I think that'll work. It's a little too much. Let's see, is that... I guess that'll do. Okay, so let's look at this one. In this case, we're looking for side A, side B, and angle A. So the pair that we know is the C's. So we're going to say 20 over sine of 105, that's familiar numbers here, equals, now in this case, we'll get A first. I'm sorry, we'll get B first. No, we will get B first, because we know angle B is 40 degrees. And so we're going to cross multiply. We're going to multiply 20 times sine of 40 divided by the sine of 105. This is going to be something that we will use the calculator to compute. So let's see what we got here. 20 times the sine of 40 over, it's kind of in the way here, there we go, over sine of 105. Just double check, make sure I'm still in degrees. Yeah, you shouldn't have to check it every time, but I just get paranoid. Okay, so we get 13.3 for side B. And I just realized you don't see my calculator. All right, so anyway, that's going to be how you type that in. Okay, so the next step is to find that missing angle, and in this case, the missing angle is A. But we're still going to find it the same way. We're going to subtract 40 and 105 from 180. So let's see what we get there. 180. I probably don't need a calculator here, but better be safe. Minus 105. It's 35. Okay, and then finally we need side A, which now we know angle A, so we can actually solve this. So we know angle A is 35 degrees. Over here, we'll use the same one we started with over here, which is 20 over sine of 150. So we should get 20 times sine of 35 divided by sine of, oh, not 150, 105. I'm sorry. All right, so let's go ahead and type that in the old calculator here. So 20 times the sine of 35 over the sine of 105. Okay, that looks all good to me. We'll go ahead and enter, and we get A is approximately 11.9. All right, well, we're going to do the same thing, but with two different triangles here. Okay, so let's, you know what I'm going to do? Just to save myself a little bit of typing, I'm just going to highlight all this work, copy and paste it down here, and just change it as we go. Okay, hopefully I don't run into too many issues doing this. All right, so let's see. On number 3, we're looking for sides B, C, and angle C. So it looks like we have our pair here, which is angle A and side A. So we'll use that as our first ratio. And it looks like we're going to want to find side B first. Okay, so my first ratio is going to be 3.5 is to the sine of 25 equals B over the sine of 35. So I'm going to cross multiply, which will be 3.5 times the sine of 35 divided by the sine of 25. This is going to be something we put in the calculator here. So let's bring that calculator back up. Use a calculator pretty frequently here. Where'd it go? There it goes. So yeah, let's go ahead and type all this stuff in. So we got 3.5 times the sine of 35 divided by the sine of 25. Let me just step back, make sure I type that in right. Okay, looks good. And so I get 4.8 if I'm rounding. Okay. Now, we don't have either side C or angle C, so we're going to have to find angle C first. To find angle C, we're going to subtract 180 minus 25 minus 35. In other words, we want to subtract both those other two angles because we know they have to all add up to 180. So let's see what we get when we do 180 minus 25 minus 35 is 120. Okay, so angle C is going to be 120 degrees. And now we can use that to solve for side C. So still going to stick with this side A, angle A, even though now I know what I need to for B. I want to use, I guess this is a good time to point out that I could use like 4.8 and 35 degrees, but this 4.8 is rounded, so that might have a bad effect in trying to solve for this last unknown, to solve for the side C, because if I throw in a rounded number here, it's going to this will just be even more off. So make sure you're using the given information and not the information that you found. Especially because like if you got this number wrong and you try to use that over here, then you know you're going to be kind of doomed from the beginning. Okay, so we got 3.5 times the sine of 105 divided by the sine of 25. All right, so let's go back to the old calculator. And so we got 3.5 times the sine of 105 over the sine of 25. Okay, it's all in there. 7.99. Okay, so it's basically like 8.0 if we're going to round it. Okay, so let's see, we got 4.8, 120, 7 point. Did I type that in right? Hold up. C is to, oh, Okay, I made a little mistake here. Let's just back it up because this should actually be 120, not 105. Sorry about that. So that means 3.5 times 120, sine of 120. We're going to have to put that in the calculator again. My bad. See, that's what happens when you start copy and pasting stuff. You miss out on changing a little thing. Could throw everything off. Okay, so let's try that again. So we get 7.1, or 7.2 rather. Okay, now that's looking good. Now let's look at number 4. It looks like the pair that we have is this pair of C's. We got the side C, angle C. So we're going to have 45 over the sine of 135 equals, we'll go ahead and get B first because we know angle B is 10. And we'll wait to get angle A at the end, or after we're done with this. So we have 45 times the sine of 10 degrees divided by the sine of 135. Go to the calculator. We'll type that in. So 45 times the sine of 10 over the sine of 135. 11.1? Yeah, 11.1. To find the last missing angle, which in this case is angle A, we're going to do 180 minus 10 minus 135. And now, let me go ahead and get this calculator out of the way. There we go. So yeah, we have 180 minus 10 minus 135. It's 35. Are you kidding me? Is that the same thing? Huh. Go figure. All right. Well, it is what it is. So, so let's go ahead and now we can start trying to solve for that last missing side, which is side A. So we've got, let's go ahead and change this back to the C's. 45 over the sine of 135 equals, what do we still need here? Side A over the sine of angle A, which we just found to be 35 degrees. So 45 times the sine of 35 divided by the sine of 135. Let's go ahead and type that in. 45 times the sine, what was it, 35 over the sine of 135, and I get 36.5. All right, so that's the first half. There's just a few more problems like this on the back, but the only difference is you're going to be sketching the triangle out. So let's take a look at those. All right, so for this next section, we're going to have to sketch out a triangle as well. So I usually just draw the triangles pretty loosely. I'm not trying to draw them to scale or anything. I just want to make sure I have the correct angles sort of aligned with the correct sides. So let's see here. We got angle A is 102.4. So as I sketch this, my angle A, I'm going to make it like a little bit more than 90. So like this would be a 90-degree angle. It's a little bit more than that. So I'm going to kind of move it out here. And I will label it with 102. Go back to red here. Yeah, here we go. So 102.4 degrees. Angle C is going to be 16.7 degrees. And side A is going to be 21.6. And we need to find angle B, side B, and side C. So what I might do here is just create like a little answer box so I know I can sort of keep my eyes on the prize here and say, okay, well, I know I'm trying to find angle B. I'm trying to find side C. and I'm trying to find side B. So it just gives me a little spot here to record my answers as I go. Kind of keeps me, you know, a little bit more focused too, I find. Okay, so anyway, I'm trying to spend too much time here making this look good. All right, so let's go ahead and start solving for this. So, you know, if we want to solve, let's say, so do we have like a pair here? It looks like our pair here is going to be A and A. So I'm just going to steal one of these. Might as well just steal the whole thing, I guess, because we have to do that same thing with this. Is this all going to fit? No, of course not. But that's okay. We will I'll make some adjustments here. Scoot this over. Basically, just do this one step at a time. Okay, so the first thing we're going to do is we are going to solve for, let's see here. So we've got A and A, and the other angle we have is, oh, wait a minute. Oh, yeah, we've got C. So yeah, well, we want to find side C first here, because we got angle C, but not side C. So, so let's go ahead and start setting this up. I will use my A's here. So I've got 21.6 over the sine of 102.4 equals side C over sine of 16.7. So side C is going to equal 21.6 times the sine of 16.7 over the sine of 102.4. So let's see what we get for C here. Break out the handy calculator. You know what I'm going to do, y'all? I'm going to actually move this calculator down a bit. You don't really need to see me pressing the button, so I'll just kind of, I'll keep it over here. Okay, so we need to do, what was it again? 21.6 times the sine of 16.7 over the sine of 102.4. All right, so I get my C value is approximately 6.4. Okay, let's get the missing angle here, which is going to be angle B, and we will subtract the other two angles from 180. So we got minus 102.4 minus 16.7. Make this a little smaller so it fits in there. And so let's type that in. Minus 102.4 minus 16.7. And I get 60.9, okay? Usually I'll only round to the, you know, the nearest whole degree, but since they gave us angle measures that go to 1 decimal place, I'm gonna go to 1 decimal place as well. All right, so on our last one here, we're going to use the original ratio where we had both sides. So that was side A and angle A. And then so now we can find side B. So B over the sine of 60.9. And then so side B, because we don't really need this over here. Side B is going to be, let's see here, 21.6 times the sine of 60.9 degrees over the sine of 102.4. Plug that in. Oops. Let's at least grab this. So we'll change this to 60.9. Oh, lost a number there. Sometimes when I click this, it just doesn't do what I want it to do. Okay. All right, so we get 19.3. All right, so just to kind of recap here, angle B, oops, forgot to change this, was 60.9 degrees. Side B was approximately 19.3. Gotta be careful about changing those. And then side C was 6.4. All right, number 6. Basically the same setup here, y'all. We're looking for angle B, side A, and side B. So I'm just going to copy and paste this. Just, hopefully you've kind of gotten it down by now. All these problems are more or less going to be the same. Really the only difference on this side is that we are also going to sketch out the triangle. So let's see what they say. They say angle A is 24.3, angle C is 54.6. So that would mean angle B would have to be obtuse. So our triangle is going to look something more like this. This is just an estimate. This is not going to be super accurate here. Okay, so angle A is 24.3. degrees. Angle C is going to be 54.6 degrees. And angle B, we don't know. It's going to be one of our unknowns. We do know that side C is 2.68. So now let's label the rest of the sides here. So this is an angle. So this is going to be angle B. We need that. We need side B, and we need side A. So it looks like we're, the combination that we have here is with angle and side C. So we'll use that to kind of kickstart us off, and we're going to go for side A first because we know angle A. So we've got side C, which is 2.68, over the sine of 54.6 equals A times the sine of 24.3. Okay, so A is going to equal 2.68 times the sine of 24.3. This is getting kind of tedious, right? Am I right here? We're doing the same thing kind of over and over again. But, I guess good news is you only get, yeah, it's not that hard, right? So, but we do need to type this into the calculator. We've got 2.68 times the sine of 24.3 divided by the sine of 54.6. Okay, so we get 1.4 be what that would come out to be. All right, so side A is going to be 1.4. So let's go for, I guess we need angle B, don't we? So it'd be 180 minus 24.3 minus 54.6. So 180, oh, not 108. Be careful there. Come on. Minus 24.3 minus 54.6. Okay, we get 101.1. Again, let's just stick with the one decimal on this. 101.1, yeah. All right, I guess, the way we're working this out, we don't really need this extra answer box, do we? We're boxing them as we go. Okay, so anyway, there's angle B, and now we need to use that to find side B. So we'll use the same ratio that we used in the first part, which is side C divided by the sine of angle C equals B, which is what we're trying to find, over the sine of 101.1. So we've got 2.68 times the sine of 101.1 equals divided by the sine of 54.6. ton of calculator. You know, when I was saying there's a lot of calculator in this one, I'm obviously not kidding. Like, we've used the calculator quite a bit here. All right, so we've got 2.68 times the sine of 101.1 divided by the sine of 54.6, all that's good. And we get 3.2 as our side length for B. All right, so that is number 6. It looks like we got 2 more to go. 2 more to go here. So let's take a look at number 7. All right, for number 7, it looks like we got 55, 42. It's gonna be a little over 90, so we're gonna have we're not gonna have any obtuse angles on this one. So let's go ahead and sketch this out. Let's try again. I'm not trying to be too accurate here, just kind of throwing something out there. Okay, so on this one, we got angle A is 55 degrees. There we go. We got 55 degrees. Angle B is 42 degrees. And we don't know angle C, so we'll need to come back for that. Side C is 3/4, or in other words, like 0.75. And okay, looks like that's what we know. This is going to be an angle side angle scenario. And so we, hold up here. Okay, so yeah, so we need to find angle C, there we go, side A and side B. So the tricky part here is that, you know, this is all the other ones we've done so far have been angle, angle, side, you know, angle, angle, side, angle, angle, side. They all have been kind of the same case, but this is where we're seeing a different one. This is going to be the angle, side, angle case, where you're basically going to solve it the same way, but you don't have that pair of an angle and a side to like jump right into. So whereas before on all these other problems we were able to just kind of jump and start, you know, using law of sines to find the first side. In this one we're going to need to find the missing angle first. So over here we found it second, and I think we did that like on pretty much every problem up until this point. But in this case we're going to have to find angle C up front. So angle C, let's copy this part, is going to be 180 minus 42 minus 55. And so angle C will be, I don't know, let's type it in. Let's see what we got. 180 minus 42. And then we got a minus 55. So we get 83 degrees. All right, I'm going to give myself a little bit more room here. I'm going to scooch this over. There we go. Okay. So now that we know that this is 83 degrees, we can use this side C, angle C as our ratio that we know. So we'll use that as our first ratio, and then we can go and find A and B separately. So I'm just going to copy and paste the rest of this. I guess I'll go for side A first, although it really doesn't matter. Grab too much there. So yeah, let's do side A first. So we're going to start with side C, which was given as 0.75 or 3/4. Oops. And the angle measure that we just found was 83 degrees. And side A is unknown, but the angle A is 55. So we're going to do 0.75 times the sine of 55 divided by the sine of 83. So let's see here. We'll just copy this. So we got 0.75 times the sine. Oh, I forgot the little decimal there. times the sine of 55 divided by the sine of 83. And it looks like we get approximately 0.6, so 0.6 here. All right, real short sides here. I guess that makes sense because this side right here is pretty short. So that seems to add up. Okay, so side B, I guess we can suspect that's going to be even smaller because 55 degrees is bigger than 42, so we can expect this to be a little smaller. In fact, something I haven't really brought up, but the size of the angles correspond to the relative size of the sides. So like the smallest side will be opposite of the smallest angle. So since 42 degrees is the smallest angle, we can expect B to be the smallest side. Over here, C, 83 degrees is the biggest angle, so 0.75 is the biggest side. So just a little sidebar there. We'll go ahead and use our side C, angle C, as our initial ratio, and then we're solving for B. So it's going to be B over the sine of 42 degrees. So here we get 0.75 times the sine of 42 divided by the sine of 83. And we'll throw that in the calculator. Really just going to have to make one little change here. Instead of 55, we need it to be 42. So yeah, it's about 0.5. So it is a little bit smaller than side A, which is what we were expecting. All right, so there's number 7. Last problem. Let's do number 8. I'm looking at my angle measures, 28. Okay, so 104 is obtuse. So I'll just make sure when I sketch this out that I make that one obtuse. So like, something like that. So since C obviously is the largest angle, being 104, we can expect side C to be the largest side. So angle C is 104 degrees. Angle B is 28 degrees. Side A is going to be 104. Oh, no, I'm sorry. It's 3.625. Wow, going wild with the decimals there. And then so what we need is angle A. We need side B, which is this side right here, and we need side C. So this is going to be another angle-side angle where we don't have a pair explicitly, but we can find angle A by subtracting from 180. So we're going to essentially do the same set of steps that we did up here, down here. So angle A is going to be 180 minus the two other angles, so minus 104 and minus 28. Type that in, minus, what is it, 104 minus 28 gives me 48 degrees. So now I know angle A. So now I need to solve for side B and side C. So we need to change that to B, we need to change this to C. Okay, so side B. We're going to use my pair that I have now, this A, side A, angle A. So 3.625 over the sine of 48 degrees equals B over the sine of 28. And let's solve it out. Okay, so B is equal to 3.625 times the sine of 28 divided by the sine of 48. Lost my calculator. There it is. Okay, so let's go ahead and type it in. 3.625 times the sine of 28 divided by the sine of 48, which is the angle measure we just found. So we get about 2.3 for side B. And then for side C, we're going to set this up very similarly. 3.625 over the sine of 48 equals c over the sine of 104. So c is going to equal 3.625 times the sine of, what was it, 104 over the sine of 48. So now angle C here should be our biggest one. So it should be bigger than 3.6, it should be bigger than 2.3 if we did this right. Which I'm pretty sure we did. I mean, we did so many in a row that pretty confident we got all this correct. Okay, so we got 3.625 times the sine of 104 divided by the sine of 48. And there we go. It is the biggest side after all. So we get 4.7. And that's about it for today. Next time we will look at the infamous angle side case, otherwise known as the ambiguous case. There's a little bit more to it, and then on the following day we'll look at the law of cosines, and we'll go from there. So other than that, y'all have a great day, and I'll see you next time.